Hello, good morning, students. I am Dr. Sunita Tandon from RR College Alwar, and today I am going to start with lecture number 11 of special physical special branch, and chapter is chemical kinetics. I have already given you 10 lectures on this topic, and in the last topic lecture number 10th we have studied about the kinetics of subsequential mechanism reactions, and in this case we have also studied the ping pong mechanism of the chemical reaction with enzymes, and then we have studied the kinetics of ping pong mechanism non-sequential. Sequential studied, we have studied earlier sequential, then yesterday we have studied the non-sequential method of kinetics of or ping pong method. Now we have lastly seen the difference between sequential and non-sequential or ping pong mechanism. If we revise the last lecture, in that case I have told you that in case of sequential mechanism at different but fixed concentration of B is a substrate, we get different intercepts and different slopes, as it is clear from figure A. If you see the PDF of last lecture, you can see in the diagram that plot of 1 upon R against 1 upon A at different concentrations is straight line, okay, with different intercepts. In case of ping pong mechanism, we get differential intercepts but similar slope, as is clear from this figure. This figure shows they have different intercepts, okay, they have different concentration and different intercepts, but slope of each line is same. ठीक है, this thus ping pong mechanism gives only intercept effects, whereas both intercept and slope each are observed in sequential kinetics. We have studied in the last lecture we have studied about the kinetics of sequential mechanism. Now we will study about random orders and the kinetics of inhibition of enzyme catalyzed reactions. In random orders, in this ternary complex is formed in a random manner, that is, E enzyme will react with substrate A, it may form EA. Similarly, enzyme reacts with substrate B, it may form EB, a product. Then this EA reacts with another substrate B to form EAB, and EB reacts with another substrate A and form EAB. The end products of both are same, but there are two substrate and one enzyme reaction. Inhibition of enzyme catalyzed reactions. For complexation, it is essential that the substrate should be of same configuration as that of active sites of enzymes, because you know enzyme and substrate, their mechanism is like a lock and key. One particular enzymes fits for one substrate only, so key lock pattern is there. Hence, we can say कि complexation, it is essential that substrate should be of same configuration as that of active site. Then only combination or adsorption or fixing or locking takes place. Sometimes, apart from primary complex, we have ternary complexes. E combine with I and form with a reversible reaction EI complex. This is binary complex of E and inhibitor. I is inhibitor and E is binary complex. Again, EI react with substrate to form EIS, and it is again a ternary compound, complex. The substrate which occupies active sites on enzymes other than the main substrate and inhibits the reaction. Such substrates are called inhibitors. These inhibitors are of two types: reversible inhibitors and irreversible. In case of, first we study reversible inhibitors. In case of reversible inhibitors, in this case, enzymes can be isolated from inhibitor by the technique like dialysis. In this case, enzymes can be isolated from inhibitor. ठीक है, जब आइसोलेट कर लिया आपने एंजाइम को तो इनहिबिटर से, तो क्या होगा, टेक्निक होगी लाइक डायलिसिस, कैन बी आइसोलेटेड फ्रॉम इनहिबिटर by the technique like dialysis, etc. These are further subdivided into three categories. Reversible inhibitors are divided into three categories. First is competitive inhibitor, second is non-competitive inhibitors, and third is uncompetitive inhibitors. First we will see then we see irreversible inhibitors. फर्स्ट था रिवर्सिबल इनहिबिटर्स. उसमें हमने देखा कि एंजाइम जो है उसको क्या करते हैं, इनहिबिट कर देता है एंजाइम को, लाइक अ डायलिसिस. ठीक है, आइसोलेट कर देता है और एंजाइम को क्या करता है, आइसोलेट कर सकते हैं फ्रॉम इनहिबिटर. इनहिबिटर से अलग कर सकते हैं डायलिसिस टेक्निक से, और ये तीन तरह के होते हैं. देन आते हैं इरिवर्सिबल इनहिबिटर्स. In this case, there is no possibility of isolation of enzyme, as in case of reversible inhibitor, from the inhibitor, and thus in case of irreversible inhibitor, enzyme is destroyed. In this case, enzyme is destroyed completely. There it is recovered. In case of reversible inhibitor, irreversible it is destroyed. Now we will study its kinetics. रिवर्सिबल कम्पिटिटिव इनहिबिटर्स, फर्स्ट कैटेगरी ले रहे हैं रिवर्सिबल इनहिबिटर्स में से. रिवर्सिबल एंड देन कम्पिटिटिव इनहिबिटर्स विच आर ऑफ थ्री टाइप्स. वी आर स्टडिंग रिवर्सिबल कम्पिटिटिव इनहिबिटर्स. सो फार एज काइनेटिक्स characteristics of competitive inhibitors are concerned, a keeping constant concentration of inhibitors I1, I2, I3, etc. At each concentration of inhibitor, the concentration of substrate is varied, and then the initial rate is calculated at different concentrations of substrate. दो चीज़ें करी हैं, इनहिबिटर की कंसंट्रेशन बदली है I1, I2, I3, कीपिंग कांस्टेंट कंसंट्रेशन ऑफ इनहिबिटर. ठीक है, कम्पिटिटिव इनहिबिशन में I1, I2, I3 की कंसंट्रेशन को कांस्टेंट रखा गया है, और हर समय क्या करा गया है, कंसंट्रेशन ऑफ इनहिबिटर एंड द कंसंट्रेशन ऑफ सबस्ट्रेट इट वेरीड, एंड देन इनिशियल रेट इज कैलकुलेटेड एट डिफरेंट कंसंट्रेशन ऑफ सबस्ट्रेट. देन अ प्लॉट बिटवीन 1 upon rate versus 1 of substrate, 1 upon rate versus 1 upon substrate is can be obtained. If E S complex, which is E or S complex, if I is added, I is inhibitor, then with a rate constant EI complex is formed, and EI complex then give rise to no reaction, because E is enzyme and I is inhibitor, no reaction take place. And rate of this reaction is R is equal to V maximum plus into C upon alpha Km plus S, and alpha is equal to 1 plus I upon Ki dash, and Ki is equal to E into I upon Ei dash. This we can obtain from Langmuir's and adsorption isotherm and Freundlich adsorption isotherms. Therefore, rate is equal to V maximum upon lambda alpha Km into S plus V maximum, or 1 upon R is equal to alpha Km upon V maximum as substrate plus 1 upon V maximum. If we plot a graph between 1 upon R and 1 upon S, we get a slope, and intercept of this is equal to 1 upon Vmx, and slope is equal to Km upon Vmx. ठीक है, next, if the straight line obtained and all these straight lines for different but fixed concentration of inhibitors are converging at the same point, as you can see in the reaction 2, as you can see in the reaction diagram 2, if straight lines obtained and all these straight lines of for different but fixed concentration, like last diagram, fixed concentration of inhibitors are converging at the same point, these are converging at the same point on the rate axis, the inhibition is competitive. The inhibition is competitive. Inhibition is competitive. ठीक है. Then such a plot is an important experimental characteristic for identification of competitive inhibitions. So far as kinetics rate equation for competitive inhibition is concerned, the rate equation or rate law is given by rate is equal to K max, R max, concentration of S plus Km into 1 plus I upon Ki. R is initial rate, Km is Michaelis constant, Ki is formalization constant, and inhibitor enzyme complex, and I is inhibitor concentration. Taking double reciprocal of this equation, we get 1 upon r is equal to 1 upon r maximum plus kmi plus I upon ki upon r max, equation number 2. I is constant, s is varied. If we plot a graph between 1 upon r and 1 upon s, then slope is equal to km into 1 plus I upon ki upon r max is, or km upon r max is equal to km into I upon ki upon r max. Primary plot for this अपन 1 upon r और 1 upon s में खींचें तो एक स्ट्रेट लाइन होगी with the intercept of 1 upon r max is equal to I, and slope will be equal to km upon 1 plus I upon ki upon r maximum. Plot between slope versus I is of secondary plot, which with intercept is equal to km upon r mx. Slope is equal to km upon ki r mx. Therefore ki is equal to intercept upon slope. ठीक है, इधर स्लोप देखो आप, स्लोप किसके बराबर है, के एम अपॉन के आई आर एम एक्स इज इक्वल टू आई. ठीक है, के आई इज इक्वल टू इंटरसेप्ट अपॉन स्लोप, तो के आई इज फॉर्मेशन कांस्टेंट. प्लॉट बिटवीन स्लोप एंड आई इज ई सेकेंडरी प्लॉट, एंड प्लॉट बिटवीन 1 अपॉन आर एंड 1 अपॉन एस इज ई प्राइमरी प्लॉट. Hope you will understand this kinetics. Non-competitive inhibitors, regarding non-competitive inhibitors we will study in the next lecture number 12. Thank you.